So let's see where we left off. We began talking about pi, and so today we're going to look at circumference of a circle as well as pieces of the circle, so like the arc length. So let's first off review this. The circumference of a circle is pi times the diameter. So one of two ways, pi times d, or you can remember it as 2 pi r. Both of these are equally valid. And of course, pi, we generally approximate to be 3.14. Oftentimes, we're going to leave it in terms of pi. So we have to know how to manipulate and move pi around. And so, of course, the diameter being twice the radius, these are equivalent situations. All right, so let's look at example 3. You probably will need your calculator out to estimate things, to go quickly. So here, we're going to find the circumference of the circle. We're going to write the answers in terms of pi, and we're going to round to the nearest hundredth. So 2 ways of writing the answer. So this first one here, we recognize that is a circle. I'm going to start with my formula. Why did I use 2 pi r instead of d? Because they gave me r. Because they gave me r right there. So let me go ahead and substitute in the 9 there. So c equals 2 times pi times 9. And one answer is exactly this. 18 pi meters. 18 pi meters. So estimating that out is approximately 56.52 meters. Both of these are my answers. So the question, of course, answers this. How many meters would I have walked if I walked all the way around the circle? This is an exact answer right here. And this here is an approximate answer, about 56.5 meters all the way around. Let's look at part B. The difference, of course, here is that I'm given diameter there. So in this case, I'm going to use circumference is pi times d because they gave me the diameter right here. So c is equal to pi times 6.3. Now I could have just written that as my answer, as in 6.3 pi. And this is an exact answer. And then, of course, we plug that into our calculator to get an approximate value. 19.79. And don't forget units. Feet all the way around. Now that we know what we've reviewed the circumference of a circle, what happened if we only went around part of the circle? So a partial distance around the circle. So arc length is different than arc measure because arc length is about distance. Arc length is about distance as opposed to an angle measure, which only tells us how wide the mouth is open, as opposed to the actual distance walked or run or whatever around part of the circle. All right, so there are 2 ways to look at it, and the first one looks like this, that arc length, and usually we're going to use the letter L just for that, is equal to part of the circle. Arc length is part of the circle, a piece of the circumference. So a part usually is in terms of a fraction. And the circumference is the circumference itself. So it's going to look like this, where length is equal to the measure of the angle over 360 degrees. Because notice that this part right here is the part. It's just the fraction. What percentage, what fraction of my circle? And then the other part is the circumference. And we can just say C for circumference, or you can say 2 pi r. So it's just a piece of the circle. Piece of the circle. In this case, specifically the circumference of the circle. Now, another way to look at it is if you prefer to think of it as a proportion, you can look at it as a proportion. And remember what a proportion is? It's a fraction equals a fraction. So the length over the circumference is going to be equal to m over 360. A part over the whole is equal to part over the whole. So either one of these works well. If you prefer to set it up logically like this, or if you prefer to set it up kind of as a sentence like this, where the length is a part of the circle. Either one is sufficient. I think for speed, this one's probably slightly faster if you're looking for L. If you're looking for L. All right, so let's take a gander at our example here. We're going to find the length of the darkened arc, and in this one it's a little bit harder to see, so just go ahead and make sure that the 20 right there is the darkened part, 20 degrees. Okay, we're going to write the answer in terms of pi, and we're going to round to the nearest hundredth as we did before. So remember that this right here, the degrees, is the measure. The degrees is the measure. And this one right here I recognize as the radius. You do not have to write these down in future. You're going to check that you know the parts. All right, so our length is what we're looking for. The length is equal to a piece. So the piece is 20 over 360, 20 degrees over 360 degrees. And now we're going to multiply this by 2 times pi times 9. So notice that my circumference formula, 2 pi r, I chose to use 2 pi r because of the radius given. Now at this point, we can just start cleaning things up using simplification. Notice that the 10s drop out here, the zeros can drop out. I can divide by 9 here and 9 here to get 4. And notice I can divide by 2 and 2 there to get a 1 and a 2. Oh, and I can divide by a 2 again there to get 1 here and 1 there. So notice what happens here. Everything drops out except for pi. Okay, so that means the length is equal to pi inches, or approximately 3.14 inches. All right, so now let's look over here. And the darkened part we see here is right here, the 120 measure. All right, so the length, of course, is going to be equal to the part, the 120 over the 360. And we're going to multiply that by 2 times pi. Whoops. Not 2 times pi on this one. Why not? Because this is my diameter. So I can simply just say times pi d. Now I can start to reduce things. As we saw earlier, the zeros coincidentally drop out again. Won't always happen like that. I can divide 15 by 3 to get 5, and over here by 3 to get 12. And once again, notice that I can divide by 12 here to get 1 and 1. So notice what's left, a 5 and a pi. So length is exactly 5 pi and is approximately 15.71 feet, and feet need to be the unit on both of those.